All right, number 53 and 4.1 is just asking you to find a linearization of a function here, y equals e to the square root of x, at a particular a value. So all we need to know here is that asking you to find a linearization is just asking you to come up with the equation of a tangent line. That's it, which is something we've been doing from back in chapter 3. So, two things we need. First of all, we need to come up with our point of tangency. That's the easier one, so I'll do that first. We're going to take our function y and just evaluate it at this a value right here, so y of 1. That's going to be e to the square root of 1 power, which is just 1, and you just end up with an e right there. And so that means that the ordered pair of 1, comma, e is our point of tangency, and that's one of the two big things that we need to come up with to get the equation of our tangent line. The second thing that's going to be a little bit harder, we need our derivative, eventually evaluated at 1, but not yet. So let's find the general derivative, dy dx of e to the square root of x. Anytime we're differentiating an exponential function, we begin with the same base, e, to the same power, the square root of x, multiplied by the derivative of that exponent. It would be awesome at this point, everybody, that if we just knew that the derivative of the square root of x was 1 over 2 root x. Now, the reason for that, guys, is because the square root of x is just x to the 1/2 power, and when you apply the power rule to that, it's a 1/2, same base x to the negative 1/2 power, and that simplifies to what we just wrote here. Now, that's where we're at for the derivative. Nothing really simplifies right there, so I'm just going to leave it at that spot right there. And, okay, let's just go ahead. I'll try to use a good notation right here. dy dx, our derivative, evaluated now when x is equal to 1. All right, so let's take this expression right here and put in a 1 for all the x's. So this is e to the first power, that's just e, times a 1 over 2 times the square root of 1 is just a 2 there. So we end up with a 1/2 e or an e over 2. And that right there, guys, is the slope of our tangent line. We've evaluated the derivative at the point of tangency. So, with these two pieces of info right here, that should be everything we need to get the equation of our tangent line. Starting in point slope form, it's going to be y minus your y coordinate here, which is e, equals your slope, e over 2, and then in parentheses, x minus the x coordinate of your point of tangency, which is 1. Now, one little rule for linearization here, they always want the answer written, or I should say solved for y, because we're usually going to call that something a little bit different at the very end. And I think in this case, there is something to be gained by distributing that e over 2, the slope, into the binomial. So that next step is going to be y minus e equals. This will be an e over 2 times x, and then minus, rather than just writing this as e over 2, I'm going to write that as a 1/2 e. I think you'll see why in just a second. And then to solve for y, we're going to add an e on both sides, and of course, that's a 1e there, everybody. Those cancel, and we end up with y equals, all right, we've got e over 2, that's your slope, times x, and then what's going on right here? Negative 1/2 e plus a 1e is going to give us a plus 1/2 e. So that's the equation of the tangent line. Now, the only thing that's different here, guys, is in 4.1 with a linearization, instead of putting a y there, we tend to call that function L of x. So that's how I'm going to express my answer right there. And all right, that's what we came up with then for the equation of this tangent line here in problem number 53. They didn't ask you to do anything with it, so this is where we stop. Once we get L of x, that's the equation of our tangent line to this particular curve at the spot where a is 1.